we talk about the gravity acceleration. Have you wondered why there is a gravity force? That is due to the universal law of gravity. Okay. Newton claimed that there's an attractive force between any two objects. The attractive force is proportional to the product of the two objects, and is inversely proportional to the distance squared. In other words, say this is mass 1 and mass 2. So there's an attractive force that pulling them towards each other. And so the larger the mass, the stronger is the attractive force. And also, the farther away, the weaker the force. And it is inversely proportional to the distance squared. So, but you may wonder why there isn't a force between a table and a chair. In fact, there is, but it's just very weak because of this gravitational constant. I would require you to watch this video on this link, and Newton's dark secret, and you don't really have to watch the full video, and watch to the part that he invented or he discovered the gravity, and look at the discussion and see what you think. Again, gravity between two objects is proportional to the product of the mass and inversely proportional to the distance squared. And the fact that we don't feel the attraction between any two objects, a regular object, is because it is very small, very weak, because of this constant is 6 times 10 to the negative 11, or I'm not sure, 27 or something. This constant is very small, and it is calculated by this formula. But if one of this mass is huge, like the Earth itself, and then the attraction between, say, a book and the Earth is very significant. So you will see that the book or a soccer ball will fall to the ground because of the attraction. One of the assignment of this week is to watch these two YouTube video. If you had this file of notes, you click this link, and the video about Galileo, the great scientist about several hundred years ago. And Galileo has had a lot of great discoveries, is an important scientist. So it's good to go through this video, and then you will be asked some questions just to see if you how you think about this video, how do you think about Galileo or Newton, and so on. So I'm not going to show the video at this moment because the limitation of the video size. And so here are the questions, sample questions in the assignment. And what did Galileo trying to find out by climbing onto Pisa Tower? And there was a tower in Italy. It's leaning, it's tilted, and this scientist is so brave that he tried to see if everything fall to the ground with the same speed. And so quite an interesting story. In fact, Pisa Tower is one of the tourist attraction in Italy. So if you ever get to tour the Europe, and this is one of the sites to visit. And who first postulated the gravity? Is it Newton or is it Galileo? So you think about it. Okay, why does this formula not hold? So this is the formula we talk about in class, and so how far an object will fall or free fall, and it is determined by this formula and depend on the time. The longer time passed, and the longer distance it will fall, and it would be half gravity, which is 9.8 times t squared. For example, if for 1 second, okay, and you plug in 1, and 1 square is 1, and then that's 9.8, and divided by 2 is 4.9. So in other words, anything that you let it go 1 second, you watch, it will drop like 4.9 meters, 5 meters. It's like 15 feet, so 1 second, something. That's good to remember. What about 2 seconds? Then if you do that, it will be something like 19. Okay, and this, well, you hope this formula will hold so that you know where object is at any time. For example, you will try to see how long it takes something to drop from the sky, from airplane to ground. How long does it take? And you can just reverse this equation. But it has this limitation. It not hold anymore if we go from too high. Why is that? Because this is assuming that there is no force that resists the falling. Actually, when you fall, it's like when you do the skydiving, there was a lot of air resistance. The only first few seconds, and this formula works real well. After a while, and then you sort of reach a constant speed, and where the air resistance is balanced with gravity force, so you just go falling down with a constant speed. So because of air resistance. Under what circumstances a feather and a ball will fall to the ground with the same amount of time? Oh, well, and if there's no air, and there's experiment, I think in the video, and if you put the feather and the ball, both of them in a vacuum jar, and you will see that they fall at the same rate. But normally, if you have a feather, it's very light. If you drop, it sort of like takes a long time for it to sort of swing around and finally bottom of the ground. Take several seconds. That's because the feather's weight compared to the air resistance is very little, and so it is very significant for the feather, the air resistance. So because of the air resistance. Okay, when there's no air, they will fall to the ground at the same amount of time. All right.